All right, so for problem number 12, it says find the degree 5 Maclaurin polynomial. Oops, I don't know. Sorry, I don't know why my screen keeps rotating. For the following function, f of x equals 5 plus 3 sine of 2x. So they give you the formula again for the Maclaurin polynomial for degree 5. And what I'm going to do is just expand this out for us. So because we want to write out a degree 5 polynomial, that means that your Maclaurin polynomial involves 5 terms, right? So the first term is just the function value times x of 0 divided by 0 factorial plus f prime of 0 times x to the first over 1 factorial. And then you keep doing this until you get to the basically degree 5, right? So f double prime of 0, x squared over 2 factorial, plus f triple prime of 0 times x cubed over 3 factorial, plus f quadruple time of 0 times x to the fourth over 4 factorial. And then lastly, the fifth derivative evaluated at 0 times x to the fifth over 5 factorial. So what I did here was just expand out our formula. And what I'm going to do is now do some computation on the side here, right? So aside, what I'll first do is write out basically my function and the 5 derivatives. And right next to it, I'm going to write out their function values when I evaluate them all at 0, right? So we begin with f of x is equal to 5 plus 3 sine of 2x. So if I evaluate this at 0, you get 5 plus 3 times sine of 0. So that's just 5, since the 3 sine of 0 is all just 0. Okay? Now, if I do f single prime, or the first derivative, the 5 goes away. Your derivative of 3 sine 2x would be 6 sine of 6 cosine of 2x. So I needed to apply a chain rule for derivatives. And if I evaluate this at 0, just remember, cosine of 0 is going to be 1. So 6 times 1 is 6. All right, now we do this again for the second derivative. The derivative for cosine is now going to be negative sine. So you get negative 12 sine of 2x. But if you evaluate the second derivative at 0, you're going to get 0. So that means that this term in our formula is just going to be 0 there, the third term, the one that involves f double prime. Now, if I do f triple prime, we get negative 12 cosine of 2x. No, sorry, negative 24 cosine of 2x. And if I evaluate this derivative, we get negative 24. Now I do f quadruple prime. This will be 48 sine of 2x. Evaluate this at 0, you get 0, so guess what? The fifth term in our formula now becomes 0. And we do the fifth derivative. That will be 96 cosine of 2x. So if I evaluate our fifth derivative, that's now 96. All right, so I only have four more. I only have these 4 terms to like basically work out. So for the first term, I'm just going to slide this down. See if this allows me to. All right, cool. Some things just got a little mixed up, but I'll fix it. This would have been f triple prime. That's f quadruple. There you go. All right. So this first term, f of 0, we know is going to be 5. X to the 0 is 1, and 0 factorial is 1. So that first term is going to be a 5 here. For my next term, f prime of 0 was 6. So we have 6 times x to the first, which is just 6x. 1 factorial is 1, so it's 5 plus 6x. The third term we're skipping is going to be 0. So I proceed to the fourth term in our sum. So f quadruple prime of 0 was negative 24. X cubed divided by 3 factorial. So 3 factorial is 3 times 2 times 1, which is 6. So this would give us negative 24x cubed over 6. And lastly, I can say lastly because the next term after was skipped because that's 0. F to the fifth prime of 0 was 96. And we have 5 factorial. So that would have been 96x to the fifth over, let's see, 5 times 4 is 20. 20 times 3 is 20 times 3 is 60. 60 times 2 is 120. So this is 120. And you could have reduced this further if you wanted to. You could have said your final answer should be 5 plus 6x minus 4x cubed. 96 over 120, if you reduce that completely, that would be 4x to the fifth over 5, as 24 can go into both 96 and 120 evenly. So this would have been my final answer. There were 2 terms, namely when we were dealing with the even, these even values, we got 0, so they went away.